Okay, so yesterday we were talking about start of proteins and different levels of protein structure, as well as what makes protein is the amino acids, thing that has amine group as well as carboxylic acid functional group attached to. And that's what slide. Which was that? Slide 18. Yeah, that's where we were at yesterday, and talking about how protein structure can be altered if you change temperature or change pH. Slide 18. Yeah, okay. All right. So structure changes readily if you heat up or change pH. As I was saying, you can cook steak with heat, and structure of protein changes, then things like Maillard reaction happen. So that's when sugar, fat, charring, becoming crusty. Nice steak crust happens. So yeah, that's one alteration. And curing meat, curing prawn, things like that. If you cure them with acid, like if you leave it in vinegar, you can preserve them because they change the protein structure and they don't go bad that fast. Yeah? So those things can be altered because secondary interactions hold its shape for proteins. Yeah. And temperature, if you heat up the molecules, whatever, atoms start moving fast and they can just fall apart from each other. And it affects spatial arrangement if you do so. The functional protein is based on the shape, so if you change the spatial arrangement, the function will be lost. So yeah, if it's DNA, you can see hydrogen bonding happening between CG connection and AT combination. Yeah, that can be all broken down. And that's probably the reason why you can do things like sterilizing with hot water. Because if there is a microorganism which is based on basically protein organisms, so yeah, if you use hot water, you can kill them. You can sanitize things. Unless it's tardigrades, the water bear. Have you seen them before? Yeah? In biology, you might have heard of that. Okay. Well, tardigrades, if there was one person on the Earth, there are millions of them. So this planet is actually infested by tardigrades. There are more tardigrades than human. Okay? About a million times more, or even more. They live in water, like drop of water, like water dew, very small. They usually eat moss. So as long as there's water, they can come back to normal their life. It's funny because if they don't have water, they just go into this sleep mode, and then when they're sleep mode, they don't die. They can survive for 120 years. They can survive in anywhere, virtually anywhere on Earth, as long as it's not in like magma. They can survive in boiling water. Astronauts took them to outer space. They survived this full vacuum. If it's human, when all the air gets sucked out and everything boils off, and it freezes. So humans wouldn't survive in perfect vacuum, but they do. They don't also die with acid. They don't die with base. So pretty much indestructible protein-based organism. Yeah. But yeah, they're very small. So yeah, you can only see it under a microscope. They lay eggs though. I'm not sure if eggs are susceptible to any pH or temperature change. But yeah, they're pretty much indestructible. All right, effect of pH. Chemically speaking, what can we change? Changing pH will have a significant impact on ionic bonds, not only the hydrogen bonding, because ion dipole is also an interaction. And if there was something that's positive, acid, or something that's negative, hydroxide, they can disrupt bonds between amine component and also carboxylate component in protein. As well as of course hydrogen bonding. Increase in pH will change NH3 plus into NH2. Yeah, it will get rid of the hydrogen that was attached to and making nitrogen as ion. No longer ion because it's got less hydrogen there. Ionic bond can be broken. So within protein you can find hydrogen bond and hydrophobic interaction. So that's really what you call dispersion force between component and component. Yep. Disulfide, it also makes bridge like so, and ionic bond here. So this curve here, this spatial arrangement can be broken if this ionic bond was broken or hydrogen bond, this interaction was disrupted. Hydrogen bonding, as I was mentioning, it's something else that gets affected. It is important to note that these bonds occur between side chains and not the amide functional group of the main chain. So what it's saying is that they define a shape. They keep the shape. Finally, raising the temperature, thermal energy, so instead of pH, will increase the amount of movement of atoms within the protein. This causes secondary interactions such as hydrogen bond and dispersion forces to be disrupted. And secondary, tertiary, quaternary structures of the protein will be altered, causing its function to be impaired. It's basically saying if you cook them, they will die. Yeah. Okay. So that was that. Yeah. And as I mentioned before, I had 4 vegetarians last year, so they were like, hey. Anyway.